probably done this. You type an address into your GPS, it calculates the mathematically perfect route, and then you immediately turn the wheel in the opposite direction because you know a better way. That exact human impulse, rejecting a machine's perfect calculation in favor of our own judgment, is happening right now on the front lines of enterprise software development. Look at this split-screen comparison. On the left, you see an engineering team's dashboard, a sharply rising green line showing their new AI model hitting 98% accuracy. But on the right, product analytics show a plummeting red line, the user opt-in rate for that exact same feature. This exposes a classic product management mistake, assuming that machine learning precision automatically equals product success. It doesn't. When people are handed an AI-generated answer without understanding how it was calculated, their default defense mechanism is skepticism. They ignore the tool and go back to doing the work manually. An AI model that correctly predicts outcomes 98 times out of 100 is completely useless to your business if the user refuses to click apply even once. When you see that sudden drop in usage, you need a structured way to investigate. This brings us to a standard diagnostic tool, root cause analysis. Let's say your product recommends content, and clicks have suddenly halved right after an algorithm upgrade. The root cause analysis framework forces you to break the problem down methodically. You start by clarifying the details of the drop. Is it sudden or gradual? And then you isolate your customer segments to see if the decline is tied to a specific platform or region. At this stage, you have to stop looking at system health metrics, like server uptime or model speed, and start looking exclusively at the behavior of these isolated user groups. You are measuring trust as a hard, quantifiable data point. Diagnosing an AI product failure requires translating qualitative human friction into measurable behavioral product metrics. Instead of staring at server logs, you need what we can call a trust dashboard, an operational view of how humans actually interact with your AI. Look at this first metric on our dashboard, the intervention rate, or edit rate. This bar chart compares how often users correct the AI's output. A high day 1 edit rate is normal. If it stays high by day 30, they don't trust your model. Now, watch as the dashboard expands to show the ignore or opt-out rate. This pie chart reveals the percentage of total sessions where a user saw the AI suggestion and completely dismissed it to do a manual search. Finally, let's add time to action. This downward trending line graph tracks the average number of seconds it takes a user to click approve. As their confidence in the AI grows, that hesitation time should measurably decrease. You can then cross-reference these behavioral metrics with direct qualitative feedback. For example, using the Net Promoter Score, you can see if the users who exhibit trusting behavior actually align with your enthusiastic promoters. Tracking these specific workflow metrics reveals the true hidden gap between what the machine calculates and what the human actually accepts. Once you know how to measure trust, your job shifts. You have to actively manage user adoption over an extended timeline, rather than just hoping they figure it out. This cohort analysis heat map illustrates that process. It tracks groups of users over several weeks. You can see high intervention rates, the warm colors, cooling off into low edit rates as tenured users build confidence and stick around. To get there, your first step is an audit. Go to your current product dashboard and forcefully separate your technical model metrics from your behavioral trust metrics. Don't let a high accuracy score hide a low adoption rate. Second, build frictionless feedback loops right into the workflow. If the AI makes a mistake, the user needs a safe, easy way to correct it without feeling like they broke the system. And crucially, use your onboarding experience to explicitly set expectations. Tell a user upfront where the AI might struggle, and you prevent a catastrophic loss of trust when it makes a minor error. Your ultimate goal is full behavioral reliance. That's the point where the AI stops being a novelty and becomes an invisible, trusted utility that the user relies on every single day. Algorithms handle the calculations, but the human user holds the final decision. Managing these trust metrics is what ensures that technical precision actually results in a product people are willing to use.
Thanks for watching. Subscribe and like.